Okay, number 14 says, find the greatest common factor of 42 and 98. I am not about to list all of the factors of 98 right now, so what we can do is we can create two separate factor trees. Let me do that first. We have the factor tree of 42. And I have the prime factorization of 42 being 2, 3, and 7. Okay, factor tree of 98. All right, it's even, so I know I can go 2. A half of 90 is 45. A half of 8 is 4. So we have 49. Break 49 down into 7 times 7. And I have the prime factorization of being 2 times 7 squared. I'm going to write it out for this example. I'm going to actually need it written out. Let me center this off a little bit here. All right, so I have the two prime factorizations of 42 and 98. Now, if I want to find the greatest common factor, I have a little method that I usually teach my students, and it's called the dance method. You know, pretend like you're at a dance and you're going to battle someone in a particular dance, maybe the Macarena, and I see that 2 and 2 are both one in the top and one in the bottom, and they're going to have a little dance off to the Macarena, and one of them is going to win based on crowd noise. So one of them is going to win and one of them is going to lose. So one comes out in the winner's circle and one unfortunately does not win. Looking again in the top and the bottom, a 3. I don't have a 3 anywhere in the bottom, so 3 will not be participating. I have a 7 in the top and I have a 7 in the bottom, so they're going to have a dance off, some particular song, and one of them is going to win and one of them is going to lose. And then I have one solo 7 left in the bottom and nobody else in the top to match up with it. So this 7 is not going to be part of our answer. Now, what are we going to be doing with these two numbers of 2 and 7? We're going to be multiplying them together. And 2 multiplied by 7 is equal to 14. So the greatest common factor of 42 and 98 is going to be 14. All right, now we're going to talk about the least common multiple. We're going to actually do the same method. We're going to do the dance method, but there is going to be a little difference between the two of them. So let's just do the factor tree first. All right, factor tree of 26. 2 and 13, factor tree of 39 is actually 3 and 13. Let's get our two factor lines going here. All right, same idea. We're looking for dance partners, one on the top, one on the bottom. I will circle the partners. They're going to have a little battle. One of them is going to win, and one of them is going to lose, unfortunately. And then if you recall from the last example in greatest common factor, we didn't use these outside numbers that didn't have partners. When you're doing the least common multiple, you are going to be using them. So the 2 comes up in the answer, and the 3 comes up into the answer. We multiply them out. Let's see. 3 times 2 is 6, and 13 times 6. You're not going to have access to the calculator, so 13 times 6 can be written in 2 different ways. Let's do it a speed way. 10 times 6 is 60, and 3 times 6 is 18 for a grand total of 78. 78 is the LCM. All right, next one is going to use the same idea of the LCM. How many of the first 100 counting numbers are divisible by 2, 3, and 5 all at the same time? So if I were to list out all of the multiples of 2, all of the multiples of 3, and all of the multiples of 5, you're going to land at a common number called 30. And if I multiply 2 times 3 is 6, 6 times 5 is 30, we have a common multiple between them. All right, so if I know that 30 is the least common multiple between those three numbers, between 0 and 100, what other numbers does 30 go into evenly? Well, 30 goes into 30. 30 also goes into 60 without a remainder, and the last one would have to be 90. So the question is, how many of them? I would say that there are 3 numbers between up to 100 that are divisible by 2, 3, and 5 all at the same time. Simplify, basically we are going to be reducing this fraction. I see that they're both even numbers. I'm thinking back to an earlier video I made for this review of all of those divisibility rules, and I'm just going to use the simple one, divisible by 2. So let's take 280 and 168, divide them both by 2. Let's cut them all in half. A half of 200 is 100, a half of 80 is 40. We have 140. A half of 100, a half of 60, and a half of 8. A half of 100 is 50. A half of 60 is 30. That's 84. All right, I can use any particular divisibility rules that I want. If you're comfortable, I see a 0, I see 4. I'm thinking back to that screen. They're both even. I'm going to stick to the 2's. All right, a half of 140 is 70. A half of 84 is 42. Oh, they're still even. It's taken a while. You know, if you want to use larger numbers, if you can find them quicker, go for it. A half of 70 is 35. A half of 42 is 21. And now I'm looking at 35 and 21, and I know that I could use a number other than 2 because they're not even. So I'm going to go right to 7. So 7 can go into 35 5 times, and then we have 3 times. So the simplified fraction is 5/3. It didn't really say to put it into a decimal or a mixed number, so I hope 5/3 would suffice for your teacher who's grading this. All right, number 18 says order the following from least to greatest. Least to greatest, I see some negatives in there. That's really important to me. I see different forms of numbers, fractions, decimals. I see pi. I see a square root, a radical in there. All right, so let's just start with the negatives first. I see negative the square root of 8, and I see negative 2 1/10. So I guess I need to figure out what this negative square root of 8 is. And I know that it's almost negative 3, very, very close to negative 3, because I know that the square root of 9 is 3. So this is negative, approximately negative, let's call it 2.8 or 2.9. Let's stick to like 2.8. And now we have negative 2 1/10. We have 3 1/10. We have this pi, which can be, if we went to the 10th position like everybody else, we might have to go to a different position in a second. But let's stick to 3.14 right now. And the reason I'm hesitant is because I'm looking at this fraction, and this is the 1,000th position. So that is going to be 315 thousandths, which would look like this, because we have the 10th, the 100th, and the 1,000th position written as a decimal. All right, so when I compare numbers, I like to have all the same decimal positions. You know, before we continue, let me check out that pi for you here real quick. Not the pi, the square root, sorry. Okay, so it is. It is negative 2 8/10 rounded. All right, so if I'm going to the thousandth position in all of them. Negative 2,800, 3.14. I believe it's 1.5. You know, you all have that memorized, but let's just stick around it to the nearest thousandth position. All right, looking at your negatives first, I have negative 2 and 800 thousandths. I have negative 2 and 100 thousandths. This is much closer to a negative 3, so this will be your smallest integer. So let me just write them up here first. So this would be my first answer, and then this would be my second answer in the line. All right, so I am done with those. Who's next? Let's see here. Let's look at the whole numbers now. So I have a 0, I have a 3, and I have a 3. So the next smallest one would have to be this whole number of 0 and fraction, so and decimal. So we'll go here at 3. So now I have 3.14 or 3. Would you rather have $3.14 or $3.10? Okay, so I'd rather have $3.14. That would be our largest number. So that makes this number 4, and this will be number 5. All right, so if I were to write this correctly, I like students to write it out as the original problem. I will have negative square root of 8, negative 2 1/10, 315 1,000ths, let's see, 3 1/10, and pi. Okay. Number 19 says write this mixed number as an improper fraction. So this is where we take our whole number 6, multiply it by the denominator, which is 8. We're going to add the numerator 7 and divide it by your current denominator of 8. And the improper fraction would end up being, let's see, 48 plus 7 is 55 over 8 improper. Number 20, write it as a mixed number. So now we're going to work that process in reverse. We're actually going to divide. We're going to have 27 divided by 4. 4 goes into 27 without going over 6 times. 6 times 4 is 24. There's 3 left over. 3 left over. Let's see, 3 left over our denominator, which was 4. So we have answer of 6 3/4. To double check it, 6 times 4 is 24. 24 plus 3 is 27 over your denominator of 4. Okay, number 21 says find the quotient and remainder of 1,371 divided by 7. So let's see, 7 goes into 13 one time. 1 times 7 is 7. Subtract, we have 6. Carry down, bring down the 7, we have 67. 7 goes into 67. Let's see, 9 times. 9 times 7 is 63. Subtract 7, take away 3 is 4. Carry the 1, bring it all the way down. So we have 7 goes into 41 5 times. 5 times 7 is 35. Subtract. And we have left over 6. And they don't want a decimal answer. It says with a remainder. That's that old school capital R. Haven't seen that in a while, but capital R, remainder 6. So 100.